All right, so here are the notes for arithmetic series. So series and a sequence are similar. A sequence, remember, is just a list of numbers. A series is what happens if you add them together, so a sum. So a finite series is the sum of the terms in a finite sequence. So a sequence is the list, the series is the sum. A finite arithmetic series is the sum of terms in an arithmetic sequence. So here we have two rules. So the rule on the left is your rule if you know n, which is the number of terms you're adding up. A1, the first term in your list. AN is the last term in your list. So if you're doing 20 terms, this would be A20. It would be the 20th number in the list. And then 2 is just the number 2. Over here is the version that we would use if we do not know the last number in our list. So N is still the number of terms we're adding up. A1 is still the first term in the list. D is the common difference from the previous set of notes, so what you're adding or subtracting to move from one number to the next. And once again is the number of numbers in your list. Sometimes you'll see it written as sigma notation. This is the Greek letter sigma. It means sum of. This A1 will be a formula, and then you'll start at 1 and go up to some value for n. But we'll address how to get the parts we need when we get to those examples. So for example 1, find the sum of the indicated number of terms of the following arithmetic sequences. So since we don't have the last term, we're probably going to want to use this version. Now, if I work out the rules, in this case the rule is +3, I could generate all 46 numbers in the list, and then I could either add them all up, all 46 numbers, or use this equation, because then I would know the 46th. But as is, I do not know what the 46th number is, so what I need to work out is what A1 is. I need to work out, n, A1, and the difference. So n is just the number of numbers I'm adding up, so 46. A1 is the first number in the list, so 12. And the common difference, like I mentioned before, is 3. So this would be 40. So we're using this equation here. So let's see if I can get them both on the screen. So 46 is my n, 2 times 12, so 2 times A1, plus D times 46 minus 1, all over 2. Double close there. And then, so this would be S46, the sum of the first 46 numbers. So let's get a calculator. And work that out. So let's see here. So 46. Now you can type this in all at once into your calculator. You do need to be careful though with that double close parentheses. And remember that the fraction bar here is the same thing as dividing by 2. So I get 3,657. 46 times 24 plus, okay. So if we look at example 2, similar steps, we're going to find S47. So n for this is 47. The first term is 12, and in this case the difference is 4. 12 to 16, add 4, 16 to 20, add 4. So this would be 47, 2 times 12, plus 4 times 47 minus 1, all divided by 2. And once again, we go to our calculator. So 47 times 2 times 12 plus 4 times 47 minus 1, 2 close parentheses, divided by 2. So this one would be 4888. So for number 3, sum of the first 44, so n is 44. A1 is 10. Well, it looks like a 16, 10, and the common difference is 4 again. So 44, 2 times 10 plus 4, 44 minus 1, all over 2. So 44, 2 times 10 plus 4, parenthesis, 44 minus 1, 2 closes, divided by 2. So 42, 24. Now be careful, it's not asking for what the 46th, 47th, 44th number is, it's asking the sum. So if I added up all 46 numbers that follow this pattern 12, 15, 18, so 21, 24, so on and so forth, I would get 3657. All right, so sigma notation just means sum of. So in this case, we can actually do it either way. We can use either equation we want. So Let's jot these down real fast here up at the top so I can reference them. So Sn equals n a1 plus an over 2, if you know the first and last, or this one if we do not know. So what this notation means, the sum of the numbers that follow this formula, starting at the first number, n is 1, and ending at the 72nd number. So for this problem, n would be 72. To get a1, we're going to plug 1 into our equation. So this would become 3 times 1 plus 4, so a1 is 7. If we wanted to find an, in this case that's a72, it would be 3 times 72 plus 4, which is 220. Now, if we wanted to find the common difference, we can do it one of two ways. We can actually work out what a 2 is, so by plugging 2 in, so that'd be 6 plus 4 is 10, and then to go from 7 to 10 is 3. But there's a faster way. This coefficient right here is always the value for d, so 3. Now, either way we work this, whether we use this equation or this one, we should get the same answer. So if we do the one on the left, we get 72 times a1, which is 7, plus an, which is 220, divided by 2. So that's going to give me 72, 7 plus 220, all over 2, 8172. And if I do the other one, hopefully I get the same answer, 2 times a1 plus the common difference of 3, 72 minus 1, 2 closes, all divided by 2. So 72, 2 times 7, plus 3, 72 minus 1, all divided by 2. And I get 8172. So you should get the same answer either way. So for 5 here, our n is going to be 60, the number up top. A1, when we plug 1 in, we get 4 times 1 plus 5, so a1 is 9. An would be a60, so 4 times 60 plus 5, which would be 245. And then the common difference is just that coefficient there, so 4. So I'm just going to run the shorter version because with this equation, that one's easier. But if you prefer to use the longer version, by all means, you'll get the same answer. So 69 plus 245, all divided by 2. So 60 parentheses 9 plus 245, all divided by 2. So 7620. Down here for our last one. So n is 91. A1 is 3 times 1 plus 2. Apologies for the bell. 5. An would be 3 times 91 plus 2. So that's 3 times 91 plus 2, 275. And if we wanted the common difference, that would be the coefficient of 3. So 91, first term plus last term, all divided by 2. So 91 times 5 plus 2, 75, all divided by 2. So 12,740 would be our solution. And that's the end of the section.